That can be easily edited out. All right. So, we're going to use the right-hand rule here to figure out what the direction of the torque is for example number 2. All right. So what's the first step to doing the right-hand rule? Yeah, find your right hand. And where are we going to put our right hand? On the axis of rotation. So let's do that. Then what do we do with our fingers? No, you don't. Point them in the direction of the lever arm, which is pointing which way in number 2? To the left. So let's point our fingers down the lever arm. Then what do you do with it? Curl them in the direction of the force. All right. So our thumb's pointing which way? Out of the board. All right. So it's going to be what? All right. That's going to be positive, which would give us a counterclockwise rotation, all right? But the torque vector itself is pointing out of the board, so that would be a positive torque. Good. All right, so that one we'll say is positive. And that one is counterclockwise. Okay? All right, now I want you guys to try number 3 on your own, and raise your hand when you think you've got it.
They are in the air. That's the whole thing. You get it, and then you point it away.
All right, Cassie, tell us what you came up with, please. All right, so what sign is that? Positive or negative? Negative. Very good. Okay. This is negative, and that's going to be a clockwise spin. Very good. Okay. Awesome. All right. Now do number 4 and raise your hand when you've got it. You only need your right hand, Adam. Not Adam's like.
I have to edit that into your video so everyone.
There's a picture of a dove. All right. Brady, tell us what you come up with, please. All right. Brady says it's positive, and that's what? Counterclockwise. And which way does your finger point? I mean, your thumb points. Very good. Out of the board. Okay. Everybody agree with that? Awesome. Okay. Number 5. Try number 5. I think you should draw it. Your fingers won't be able to curl. Like, I can't curl my fingers backwards, so you'd have to flip your hand over.
Whenever it goes down.
Yeah, you cannot, you can't curl your fingers this way. They have to go that way.
What if we go like
You just have to put your hand on the axis of rotation and then watch. Like if I was going to do this wrong, okay, I put my hand on the axis of rotation, point my fingers down the lever arm. There's no way I can curl my fingers like that, right? So I need to flip my hand over and curl them.
What if it's like pointing directly up, like you just keep track?
Well, you still have to point your finger along the lever arm. Like if my axis of rotation was here, I do this, and then I put my fingers, and if it was pointing upward, I'd need to turn my hand over and do that. If it was pointing downward, then I would curl like that. Okay. All right. Okay, Mark, tell me what you came up with, please. Okay, the vector is outward. Okay, and so what does that mean? What's the sign? Positive. And what's the rotation? Counterclockwise. Very good. Okay, now y'all try number 6, please. All right, Garrett,
Because you're not close.
Very good. There's no torque here. Okay. Notice that the force vector here, the force vector is 180 degrees from the lever arm. So if you were to take the sine of 180, well, what would you get?
0. No 0.
0. So there's no torque, right? Well, there's none at all. Yeah. Okay. All right. So let's copy this question down and work it.
Yeah,
Work it. Work it. Torque. All right, find the magnitude of the torque produced by a 3.0 Newton force applied at an angle of 60.0 degrees to a door 0.25 meters from the hinge. What is the maximum torque this force could exert? All right, so let's go through and see if we can't work this out. Okay, so we've got our axis of rotation down here. Where's my lever arm? Very good. So right here's my lever arm. So let's kind of fill that in. All right. And then I need an angle, right? So what is the angle theta by definition in the torque equation? Very good. Between the lever arm and the force, right? So here's my lever arm. There's my force vector. So I need this angle right here. So that one's going to be 120 degrees, okay? Now, there's actually two ways that you could have drawn the picture described by the problem setup, okay? We could have had a door that looks like this if we want to. And we could okay? That picture also satisfies all the requirements from the problem, okay? Which is why the question only asks you for the magnitude and not the magnitude and the direction, because depending on which way you interpret a problem on a test or a quiz or something, you may end up drawing a different kind of force, all right? So you may have drawn your force pointing in a different direction. Now the magnitude is going to be able to be the same because the sine of 120 and the sine of 60 are the same number, right? Okay, so let's go ahead and plug some stuff in then, all right? What's my torque equation? Thank you. All right, so now let's go ahead and plug stuff in. So we've got a 3 Newton force. What's the lever arm length? 0.25 meters. And then we'll say times the sine of, and I'll just do 120, okay? All right, so type that stuff in. How many sig figs should our answer have? 2. All right, so raise your hand when you know the answer. Isaac?
0.65 millimeters.
Okay, 0.65 Newton meters. Is that what we came up with?
Yeah.
All right. Well, now let's make sure that we've actually answered the question, okay? The question said, what is the maximum torque this force could exert, okay? Now, how can we come up with maximum torque? What has to be true, Josh? Yeah, it must be at 90 degrees, okay? So if you were at 120 degrees, this is the torque you would get, but we were asked what would the maximum torque possible be, all right? So we need to go through and figure that out.
Pretty much you just look for sine theta. Yeah. So it'd just be 3 times the point. But so when it says this force, the angle isn't included in the force. No, it's included on the force. So that would be
All right, so what do we come up with then?
0.75. Is there ever a thing that's Newton meters divided by something?
All right, so we've got what is actually going to happen up here, the 0.65 newtons. But if the person adjusted their angle so that it was 90 degrees, then the maximum torque that they could get out of that 3 Newton force would be the 0.75 Newton meters down here. No, the sine of 60 is the same as the sine of 120. No. No, that one's the math. Because, I'll wait for Shivam to be quiet so I can answer your question. All right, because if you look at a sine graph, which I'm trying to get my little deal to roll up here. It's not wanting to. There we go. If we look at a sine curve, all right, then right here, that would be a value of 1. And right here, that would be a -1. This would be, this is the unit circle here. This is 90 degrees. That's 0 degrees. That is 180. Right? Yeah, and that's 270. And then right here is 360 degrees. That follows the unit circle around, so that at 90 degrees, you hit the maximum amount on a sine curve. And if you go any more than or less than 90, you are heading back down towards 0 or towards a -1. All right? Other questions?
Yeah.
What's up?
So would both of those be an answer? 0.65 and 0.75?
Well, no, the question asks what's the maximum force or torque that could be exerted. So it would.
Says find the magnitude of the torque by 3 Newton force applied.
Okay, so then yeah, then it's two parts to that question. So yeah, it wanted both of them. All right, cool. Let's look at the next question here. What is the net torque on the door pictured below? Include magnitude and direction. All right, so take a minute and draw that picture. You should write the question. Well, it says, what's the net torque on the door pictured below? Include magnitude and direction. What? All right, we got it? Okay, so if we're going to calculate the net torque on something, okay, then we're going to have a torque caused by force 1, we'll have a torque caused by force 2, and we'll have a torque caused by force 3, correct? All right, so then that means that our net torque is going to be equal to torque caused by force 1 plus torque caused by force 2 plus torque caused by force 3, correct? Okay, now torque is a vector, which means we'll have to take into account the direction of each of those individual torques, okay, so that we can get the correct sign in there. All right, let's do the torque because of force 1, okay? So let's see here. Torque caused by force 1 is equal to, what is force 1? All right, it's going to be 30 newtons times, what's the lever arm for force 1? 0. Very good. So 0 for torque force 1. All right, now let's do the torque caused by force 2. So what is force 2? 25 newtons. What's the lever arm? 2 meters. And what's the sine of the angle? All right, so they said it was 121. Now remember, this right here is 90 degrees, right? And we need the angle between this force vector and the lever arm. So we need that 90 plus that 31 to get a total of 121 degrees. Does that make sense to everybody? Okay. Yeah, if this is your lever arm right here, okay, and then we've got our force vector right here, then the angle between those is this right here, this amount. So it's 90 plus 31. Okay? All right. So what do we come up with for torque 2? Anyone?
No, 42.85.
Yep.
836,504.
That's a naked number, Brady. Nope.
No, wait, shoot. I know it. Hang on. Big meters.
Very good. All right. Now let's do the torque caused by number 3 there, by force 3. So what is force 3? 10 newtons. What's the lever arm going to be? 4 meters. And then what is the angle theta going to be? All right. Okay, let's talk about how we came up with 157 for those that need it. Okay. Again, if this is your lever arm and this is the force vector, then what we are actually looking for is this angle right here. Okay. If we say that this entire angle here is 180, then all we have to do is back up by 23 degrees, and that would give us the piece that we're looking for, right? So you'd say 180 minus 23. Okay, so type that in, and let's go ahead and get our torque value. Desire? Yes, please. Very good. Okay, now we just need to add up our individual values here, but we have one more thing that we really need to do before we can start adding them. Yeah, we need to do our direction, okay? So go back and look at your picture, use your right-hand rule, and figure out what the sign is for torque 2 and torque 3, okay? What do we come up with? What do we say for torque 2? What's the sign going to be? Positive. What about torque 3? Torque 3 has to be a negative value, okay? Good. So I'm going to come in here and put negative 15. And now when I I'm adding these, it's really subtraction. So my net torque then is going to be the 42 number minus the 15 number equals what?
27.229.
Well, let's do sig figs now.
Is it 2 sig figs? 27.
27 Newton meters. And this is, what sign does the net torque have? It's a positive value, so what's the rotation? Counterclockwise. All right, so my net torque then is 27 Newton meters counterclockwise.
If we don't write counterclockwise, is it okay?
Yeah, if you don't write counterclockwise, then that's what I will assume because it's a positive value. All right, so always make sure you double check your directions there. Questions? All right, cool. Then that's the end.